we have another problem similar to this one, except here we're given the pipe radius 0.05 meters at this point, and the 5 meter per second velocity here, and the pipe diameter 0.025 meters here, and we're asked to find the velocity at this point. So we're going to call this V1, call this V2. Now recalling that the fluid has to flow, that the fluid passing a point here in a time interval delta t has to be equal to the volume of fluid flowing here in time interval delta t. We conclude that the product of the cross-sectional area and the velocity is the same at both points. So we say that A1 V1 has to equal A2 V2. Now again, we can always write this down. It's a simple equation to remember and to memorize, but we want to think about what it means. We want to remind ourselves of why it's so we don't mess up the order of the subscripts or something, or apply the equation where it doesn't apply. Attempt to apply it where it doesn't apply. Okay. Now, we got to find the cross-sectional areas. Okay, well, the cross-sectional, well, let's actually do this. We're trying to find V2, so let's go ahead and solve the equation. V2 is V1 times A2 over A1. And I've got that backwards again. That's A1 over A2. Okay? See, it's very easy to make that kind of mistake if you don't think. And even in my case, even if you do think. So, be very careful. Okay, now, what we then want, we already know V1, all we need is the ratio of A1 to A2. Now, we could find the cross-sectional areas. The area of a circle is pi r squared, it's a circular pipe at both points. So we could multiply pi by the square of the radius here and here, and go to a lot of trouble when we don't really need to. Let me show you what I mean. Okay, A1 over A2, well, A1 is pi r1 squared, A2 is pi r2 squared, and look at what happens. Pi divides out, and also r1 squared over r2 squared is just the square root of r1, or the square of r1 over r2. Okay, so all we need is the two radii. We don't have to calculate the areas. We know the areas have to work out like this. So that now V2 is what? It's 5 meters per second multiplied by the radius of one over the radius of the other. Well, the radius here is 0.05 meters, the square of the radius of one over the radius of the other. Okay, 0.05 meters here. What's the radius here? If you're not careful, you're going to write down 0.025 meters, but what's wrong with that? Okay, well, this is a diameter, and you got to be careful. You could have mixed information like this, diameter here, radius here. So you're going to have to take half of this. That's going to be 0.0125 meters. You're going to square that, and you're going to find that the ratio, well, this divided by this is 4. And we got to square that, giving us 16, giving us an 80 meter per second velocity here. Now, I'll tell you that at 80 meters per second, water running through a pipe is not going to behave as an ideal fluid, and Bernoulli's equation is not going to give you very accurate results. It might be a good starting point, but there's going to be a lot of friction between the pipe and the water, a lot of work done by that force, a lot of pressure loss due to non-conservative forces. Bernoulli's equation only applies when there are no non-conservative forces, that is, when the fluid is ideal.